In this video, I will explain about correlation and regression analysis. This is the data that I'll be using. Jake Thomas, a marketing analyst at Digital Dimensions Inc., is performing research on various laptop brands offered by their dealership, and they have collected data. So this is the data. As you can see here, different brands: Acer, Dell, HP. This is screen size in inches and this is their price. We are supposed to conduct correlation analysis and regression analysis. Correlation analysis will be the one whereby we will find out how price varies with screen size. We want to determine what is the relationship between screen size and price. So for example, if we make a change in screen size, it will be reflected in price up to what extent. So that will be correlation. And then we will do regression analysis whereby we will include all these variables including brand, screen size and price. In the first step, I will perform correlation analysis. So for correlation analysis, I will use these variables: screen size in inches and price. In other words, we want to see how price changes with changes in screen size. And the formula for correlation is this one. So I'll be using this formula here, which is equal to correl, and then this column, and then comma, and then next column, and then parenthesis close, and that will give us correlation. If I hit enter, that gives us 88.37. So there is a possibility that you may get this number as in this format. You can convert it into percentage by clicking here, and then you can increase the number of decimals by clicking here. So 88.37% is the correlation between screen inch and price. There is another way to perform correlation analysis, and for that purpose, click on data in the ribbon in Microsoft Excel and then on data analysis. Click on data analysis, and then here you will see at the top is correlation. So double click on that, and then it says input range, like what variables are there. So I'll be using these variables. So I will select both columns, and then the next stage it says where do you want your results to appear. I want my results to appear here at this place. So I click on this one and then click on OK, and here you get exactly the same thing, which means the relationship between column 1 and column 2, which means between screen size and price, is 88.37%. Again, we can convert it into percentage by clicking on this one, and you can increase the number of decimal places by this one. So we have here 88.37%, which is exactly the same that we calculated the other way. Before I conduct linear regression analysis, I would like to make a scatter plot of these two variables. So select these two variables and click on insert, and over here you will see, click on this one and this one. This is called as scatter plot. So that scatter plot shows us the relationship between screen size. Here on the x-axis we have screen size, and on the y-axis we have price, and this is our scatter plot showing the relationship between screen size and price. We can also add here labels, and adding labels depends on what type of system you are using. There will be different commands in MacBook and Windows. I am using MacBook, so I will be using these commands. I will write here the title. To add labels, again it depends on what type of system you are using. In MacBook, you can click here on insert chart element, and here we can add here axis titles, primary, horizontal. So this one will be screen size, and we can also add here primary vertical, and that will be price. Now in the next step, I will be doing regression analysis, and for regression analysis I'll be using this command. Click on data analysis, and in data analysis you will find regression. Here is regression. Click on OK, and then you have this, and it's asking where is the Y range. So Y range is the dependent variable. Input X range means independent variable. So in this case, price is the dependent variable or Y variable. So I'll be selecting this one, Y, which is our price, and for X variable I'll be choosing screen size. So basically the idea is that we know that price depends on screen size. Therefore price is the dependent variable and screen is the independent variable. In other words, screen size is the X variable and price is Y variable. And the next question is that it says, did you include labels in this selection? Yes, I included labels. So which means this top row, the name, screen size and price, they are included. So I will click this one. And the next step is that it's asking output range. Where do you want your results to appear? I want my results to appear here at this place. That's all. So there are only 4 type of inputs: Y range, which in this case is price; X range, which is the screen size; labels, because I selected these. As you can see here, this is C1 and C1 is price, and you can also see here B1, which is the name of this variable. So I selected this one, and output range, and then click on OK. In these results, there are a number of things that are important. The first thing, most important thing, is R square and adjusted R square. That represents the relationship between these two variables, which means screen size and price, and we can also convert them into percentage. So I will click on percentage and I will increase the number of decimal places. So this shows that the relationship between these two variables when we are conducting regression analysis is 78.1% in case of R square, and adjusted R square is 77.05. There is not much difference between these two. Some people prefer R square, other prefer adjusted R square. Then the next thing is intercept, which is here, and I'm gonna highlight it. And as you can see, the value of intercept is negative 1593. So this is our scatter plot, and intercept mean when the value of X is 0, the value of Y will be negative 1593. Now let me explain this a little bit. So for instance, we have this scatter plot. If I add here a trend line, for example, if I add here a linear line, so we have like this type of line. Now as you can see over here, we have screen size, which means 0, 2, 4, 6, 8, and this is price. And we want to know when screen size is 0, what will be the value of Y variable. So for that purpose, we can extend it a little bit backward, and so somewhere here it touches. So this point where X is 0, so whatever is the value of Y at this point, this is called as intercept. So as you can see, it's very intuitive that this point will be something close to negative 1593. When the value of X is 0, so this is the 0 here, and the value of Y, this is Y, it looks like it will be something negative 1593. And this is exactly we have got here in intercept. Next thing that's important here is this coefficient of screen size. This coefficient is 177. This means that for every 1 unit increase in screen size, you can expect an increase of $177 in price of that laptop. There is another thing which is important, that's p-value. So this is our p-value, and as you can see, this is in scientific notation. It's a very small value, and as you can see here, 10 raised to power minus 8. So we can convert it into number. So click here on number, and I can also increase number of decimal places. So this is a very small number. Now the rule is that if this number is less than 5% or 0.05, we consider results to be significant. So this means our results are significant. The last thing is to develop a regression equation. And for regression equation, this equation will be used to make a prediction about price. What would happen if I make a laptop that has screen inch of 20? Now we don't have 20 here. Our maximum value is 17. Now in that case, we need an equation, and this is the equation that we'll be using. So our equation will be price is equal to intercept. This is our intercept. As you can see here, this is negative 1593 plus 177.52, which is the coefficient from here, and multiplied by screen size. So for example, if you want to make a prediction about what would be price if screen size is 25, now you will just replace this one with 25, and then it will give you an idea of price, that what the price should be. So you simply replace the screen size with 25. So 25 multiplied by 177.52, and then this is in negative, so that will be subtracted, and that will give you what should be the price. Some other information is that for each inch increase in screen size, the price increases by 177.52, which is a coefficient. You can see here 177.52 we also found here. So this is a coefficient, which means every time you increase the screen size by 1 inch, you can expect a corresponding increase in price by $177. And then R square turns out to be 0.781 or 78.1%, which means it's a very strong correlation. It also means that about 78.1% of the price variation is explained by the screen size, and because it's a big number, we can say the model shows a strong positive relationship between screen size and price. In the last step, we are going to include one more variable. So in this regression analysis, we included two variables. We included screen size and price. What about if we also include brand? But the problem with the brand is that it's nominal variable, it's name, which means we need to convert it into some number. Microsoft Excel cannot process a name. So we need to convert this Acer, Dell and HP into some sort of numbers or dummy variable. And actually, that's also one of our questions. So as you can see here, it says add a dummy variable for brand. For example, Dell is equal to 1 and all other brands become 0, and then use a multiple linear regression model to estimate the relationship between screen size, price and brand dummy variables. So we will do this thing. We will replace them with some dummy variables. In order to change these nominal variables or these names with dummy variables, we have two options. You can manually change them with numbers. So for example, Dell, you can manually enter here 1, and Acer with 0, HP with 0, Dell with 1, 1, 0. Or another option is that press Ctrl H key on your keyboard. Dell, replace it with 1. So find what Dell and replace it with 1, replace all. So I will click on that. It says all done. We made 7 replacements. So as you can see, here was Dell, it's replaced with 1, 1. Here we had Dell, it's also replaced with 1, and everywhere Dell has been replaced with 1. Now in the next step, you can say, okay, Acer replace with 0 and replace all. It says it has made 8 replacement. Here initially we had Acer and it's converted into 0, 0, and the only thing we are left is HP. Okay, let's also convert that. So here I will say HP, also convert it into 0 and then click on replace all. It says it has made 8 replacement, and here we have our data in which all nominal variables, brand names of laptops have been converted into dummy variables. So this one represents Dell, this one represents non-Dell, this one also represents non-Dell, non-Dell, this is Dell and this is Dell. Now we can conduct a regression analysis on this data. For regression analysis, again I'll be using the same command, which means I'll be clicking on data and then data analysis, but the only difference is that this time we are using this additional variable. Last time we used screen size and price, whereby price was y variable and screen size was x variable, or in other words, price was dependent variable and screen size was independent variable. Now in this analysis, we are going to include this additional variable. This one will be x variable or x1 variable, first independent variable. This one will be second independent variable, and this one will be dependent variable. So we have one y and these two x. So these two are x variable, this one will become x1, this one will become x2, and this is our y variable or dependent variable because price depends on screen size and brand. So let's conduct regression analysis. We have data and click on data analysis, and then again here we have regression analysis, and then it says what type of variables are there, where is y variable. So this is our y variable, so I'm gonna select this whole column, and then it says what is X variable. For X variable we have these two, so I'm gonna select the whole column, all 23, and then label. It says, did you select label? Yes, label is selected, which means the top row is included. As you can see here, this is C1, which means the top row, the label, which means brand, screen size and price, they have been included. So I will click on label, and then it says output range, where do you want your results to appear? I want my results to appear here at this place. So I click on this one and then I will click OK. But before I click OK, again note that there are 4 types of input in this one. One is Y range, which is price, X range, which is brand name and screen size, and labels also included, and the output range is where you want your results to appear. So our results will appear, they will start appearing from this place. I click on OK. So we have this one here. These two things, again, they are the most important, which mean regression analysis R-square, and we can convert them into percentage, and I can also expand them to increase number of decimal places. So it shows that the relationship between Y variable and independent variables is 78.31% in case of R square, or if we take adjusted R square, that is 76.15%. There is not much difference between these two. It's just a matter of individual preference. You want to use this one or this one. Then the next one is intercept. So this is our intercept, and all these values are important, so I'm gonna highlight them. So this is our intercept, which means it is negative 1562, and for brand coefficient is 40, so which means Dell brand compared to other, this is the premium price that you have to pay when you change brand. And then for screen size, it's $173. Every time you increase screen size by 1 unit, you can expect a corresponding increase in price of $173. Second last thing is p-value. Again, as you can see here, p-value is very small. This is scientific notation, and we can convert it into numbers. So click on numbers. As you can see, it's very small, and even if I increase the number of decimal places, it is less than 5% or less than 0.05, which means these results are significant. And the last thing will be to make a regression equation, so that if you ever have to make a prediction, you can use this one. So this is our equation, a regression equation, and as you can see, the regression equation is that, first of all, intercept, which means negative 1562.13, which comes from here, plus 173.54 multiplied by screen size, so it goes here, plus 40.76 multiplied by brand. So this becomes our regression equation. For example, I want to know what will be the price of a laptop if screen size is 19, which means at this place screen size you will substitute with 19, and for brand, if it is Dell, you will place here 1. If it is non-Dell, then you will place here 0. That will give you the price. This is another way to write the same equation. It's essentially all the same variables are there, just reorganized. So this intercept, you can also write it here, but this one and this one, they are essentially the same. And further information that's coming from here is that screen size is the strongest predictor, because this is 173.54, which means whatever is the screen size, multiply that with this one, and that number will become really big. So which means this screen size is the strongest predictor of price, and every time you increase screen size by just 1 inch, you can expect an increase of $173.54. Brand has a premium of about 40.76 over non-Dell, which means using this data, it means Dell brand has a premium price. So that's all about regression analysis. And again, something that's really important here, R square and adjusted R square, which tells you the extent of correlation between dependent and independent variable. This is intercept, which means when the value of X is 0, what is the value of Y? I explained it by showing you scatter plot. This is the coefficient for brand, this is coefficient for screen size, and this p-value shows if results are significant or not, and this is how we make a regression equation. And as you can see, we have answered all our question. So the first question was that does there appear to be a positive or negative correlation between price and screen size? So this is our price and screen size, and when we conducted correlation it was 88.37, which is a big number. So which means yes, there is a relationship and this is a positive. You don't see here any negative sign, which means if one variable increases, if screen size increases, price will also increases. This is called positive correlation. So yes, there is a positive correlation. And then create a scatter plot. We created a scatter plot. The next one was determine and interpret the correlation coefficient between screen size and price, and then we did this regression analysis. We had this coefficient and we did that. Another question was estimate the relationship between screen size and price. We just did it using simple linear regression model. A simple linear regression model is the one we're only considering this variable and this variable. In particular, there is only one predictor, or x variable is only 1. Then in the next step we added a dummy variable, which means Dell became 1 and all other Acer and HP laptop, they became 0. And then we conducted a multiple linear regression model and we developed an equation. And the last part is interpret the coefficient from part D. So we had this coefficient. The coefficient was 40 for brand and 173 for screen size, and we made an interpretation. We know what does it mean. What does 173.54 mean? What does 40.76 mean? What type of relationship exists between them, like positive, negative, or 0? We know this is r square. I mean, you can take any value. For example, r square is 78.31%. It's a positive number. It's a big number, which means there is a very strong correlation between them. Then we have, is it statistically significant? And this information, it comes from p-value. So here we have p-value. P-value is less than 5% or 0.05, which means it is significant.